Hello, everyone, and it's time for our final sequence of inner chapters. So today we're going to be going through functional group name nomenclature. So specifically, we're going to be taking a good look at nomenclature that involves suffixes. So one of the things we have to deal with is many of our functional groups are named not via prefixes, but instead by suffixes. So we're going to be taking some of the rules that we saw for alkenes and alkynes and just modifying them a bit to extend to these suffixes. So a lot of major functional groups include this, including alcohols, amines, ketones, and carboxylic acids. And so when we're going to be naming each of these molecules that contains one of these functional groups, we're going to end priority to the suffix. The highest priority of those groups is going to lend its name to the suffix. So for example, if I have an alcohol like ethanol, we use an OL. We also have triethylamine, propanone, ethanoic acid, and any lower priority groups, they're going to be turned into prefixes, and they're going to follow all the rules we covered in inner chapter A and B. So for example, for our final molecule, we have a carboxylic acid, which gets the priority. So that alcohol now becomes a hydroxy group. So this guy's 3-hydroxypropanoic acid. Now, first thing we have to do is identify what our relevant functional groups are, identify their priorities, and kind of get an idea of what our prefixes and suffixes are. So we're going to go ahead, start big, and then we're going to work our way through all of these functional groups. So just kind of as a major cap, we have our 10 major functional groups that contain suffixes. So our lowest priority groups are going to be alcohols and amines. Then next up are ketones and aldehydes. And then we have our nitriles and amides, so our nitrogen-containing species. Acid chloride is kind of on its own, and it's essentially a younger cousin of our carboxylic acids, acid anhydrides, and esters, which we'll go ahead and finish up with. So we're going to go ahead and start with alcohols and amines and work our way up that priority list, working through increasing complexity of these names. So we're going to go ahead today illustrate how these rules can be applied to alcohols and amines. And then next time, we're going to go ahead and continue from ketones and aldehydes right on up. So when we're going to go ahead and use these suffixes, we need a slightly different set of naming rules. So the first thing you're going to need to do is determine which of your functional groups have the highest priority, as that's going to set our suffix. Once you've identified that highest functional priority functional group, you're going to establish what is going to be that main chain or ring that contains that highest priority functional group. And if multiple of those functional groups show up, you're going to make sure that the chain includes all of that functional group. And that chain is going to provide our root name, whether it's meth, eth, prop, bute, or so on. Then we're going to add that appropriate suffix, whether it's all, amine, nitrile. So we're going to, again, choose that suffix that corresponds to the highest functional group. We're going to remove the E from that alkane, alkene, or alkyne, and then slap that suffix on, and that will, again, be our root name. Now we're going to want to go ahead and number that main chain, and we're going to always put our focus on minimizing the number of that highest priority functional group. So we're going to minimize that number before anything else. Then we're going to add locator numbers for the highest priority functional group before the prefix to establish where that functional group is located. However, what we're going to find is in many cases, this might be redundant based on the shape of the molecule and the nature of the functional group. Then we're going to go ahead and add everything else that's attached to that chain or ring using our classic rules from inner chapter A, adding it as prefixes, locator numbers for all of the other substituents. All right, so these are the general themes that we're going to be using, and feel free to keep coming back through these as we work through examples. So we're going to go ahead and start by applying these rules. And again, we're going to go ahead and walk through this first using our low priority alcohols and amines to illustrate how these priorities work. And next time we'll work our way through the remaining functional groups. So again, starting with alcohols and amines. If I start with an alcohol, we're going to use that OL suffix. Now, if alcohols appear um, as the substituent instead of the main priority functional group, they're using a hydroxy prefix. However, in this case, we're just going to stick with that suffix. So for my first molecule, I know I've got an alcohol. So I know I'm going to end with OL. Then I'm going to have to identify my main chain. In this case, it's 3 carbons. So I have a propane. Then we're going to go ahead and slam these two names together. And I have a propanol. Now we're going to go ahead and identify our numbers. So to minimize the numbering of the alcohol, I'm going to put that one position next to the alcohol and work my way up. So to identify where that alcohol is located, I'm going to name this as propan 1-all. Don't be too surprised if sometimes you see the older notation, just like we saw with alkenes, of 1-propanol. Now, for the second example, I still have an alcohol. I still have a propane chain. But this time when I'm numbering, we're always going to go ahead and start on the end. So we start on the end, that's 1. This means my alcohol is located at the 2 position. So this guy becomes propan 2-all. You'll often see this under various older nomenclatures as 2-propanol, where the number used to be put forward, which which can make things a little more complex when I have more functional groups attached. This is also found under the even older nomenclature of isopropanol. All refer to the same species. Now, in the next case, I have, again, an alcohol on an ethane, so 2 carbons. So this would be ethanol. However, when we number it, since I only have 2 positions, there's nothing that distinguishes whether the alcohol is on the 1 or the 2, unlike when looking at propane. So in this case, I get to simply name this molecule ethanol. No need to include the numbering because it would be redundant. All right, then let's go ahead and look at a cyclic compound. So again, here I have an alcohol. It's attached to a cyclohexane. So putting these together, I have cyclohexanol. Now again, when I do my numbering, minimize that alcohol. So it's 1, work my way around to 6. Now again, when I do this, there's no preference of whether an alcohol would be bound here or here, as the carbons would be, these would yield identical compounds. So putting the 1 in front of that hexanol would be redundant, so it just becomes cyclohexanol. Now let's go ahead and take a look at our amine. Now, the amines are in truth the lowest priority functional group. So if anything else has a suffix, we're going to turn that amine into a prefix. So again, if you see amine or amino, either case would indicate that presence of that amine group. Now, looking at our first group, we have an amine, and it's the highest priority functional group, so I know I have an amine. It is bound to a 5-carbon chain, so that is a pentane. So I have a pentenamine. Now we can go ahead and identify our numbering scheme, starting on either end. But it doesn't matter in this case which end I start on. Either way, I would get that nitrogen, the amine located at the 3 position. So this means that I have a penten-3-amine. Now we can go ahead and extend this idea to, again, another cyclic compound, where again, I have the amine suffix, and it's based on a cyclopentane. So, surprise, surprise, I have cyclopentenamine. And again, working through the numbering, you may notice here that it doesn't matter where that nitrogen is located. So, numbering is redundant. So, this guy is indeed named as cyclopentenamine. Now, for our final molecule, again, the amine is the priority functional group. So again, I have an amine. It's still a cyclopentane. So I still have a cyclopentenamine. However, in this case, when I do the numbering, I do have another group. So this case, I have to add in a prefix of 3-nitro, as I have a nitro group at the 3 position. However, when putting this together, I still don't need to number that the nitrogen on the amine, because it is by default 1 since it's on a cyclic compound. So this means that I have a 3-nitro cyclopentenamine. So again, starting simple, working our way towards more complex. Now we can go ahead and extend these rules a little bit more to when I have uh, higher level substituents, such as alkenes, alkynes, and when I start mixing these different functional groups. So let's go ahead and start with this first case. So now I have an amine located on a cyclic molecule, but this time my main ring is actually not a cyclohexane, it's a cyclohexene. As you can see, a double bond located here. So this means that the root that I'm going to be building off is a cyclohexenamine. Again, replacing that E with the full amine. Now again, note the big difference here in between a cyclohexane and a cyclohexene. So important to keep an eye out for that. Starting the numbering, I'm going to number that amine 1. Then the next priority is minimizing the number of my alkenes. And then finally minimizing the priority of that chloro. So working through the name, this becomes cyclohex 2-ene-1-amine. And again, you can leave the 1 off here, but it is useful when you're dealing with a mixed uh, uh, alkene compound to again denote those relative positions, though the 1 can be considered redundant. The only major substituent on this guy is the 4-chloro. So again, adding that in. This gives me my whole name of 4-chloro-cyclohex-2-enum-1-amine. Now again, dealing with a nice straight chain alkyne, my main chain is going to include that alcohol. So I have a alcohol on a heptine molecule. So again, 7 carbons. Now this time, which means I have a heptine all. So normally we try and minimize that numbering of the alkyne. However, the alcohol gets higher priority. So when I number the system, I'm going to give that alcohol the 2 position, again, prioritizing the alcohol over the alkyne. So this means that I have a hept 6-ine 2-all. Now, for our final compound, we have both an amine and an alcohol, so only one gets the suffix. So alcohols are higher priority over the amines, meaning that I'm going to base the molecule off of the alcohol. We have 5 carbons, so I have a pentane, and so the main chain is going to be a pentanol. Now, when I number the system, I'm going to want to give that lowest number position to the alcohol. So that's going to get the 1, meaning that the amine, as a result, gets that 5. So again, that main chain is the pentan 1-all. Now we're treating that amine uh, as a uh, as a substituent, so it gets the amino label instead of the amine, meaning that it is 5-amino. Bringing this together, I have a 5-amino pentan 1-all. However, one of the things we have to watch out for is as I extend these to more complex systems, what happens if I have a functional group that contains more than one of the highest priority groups? So in this case, my highest priority is going to be an alcohol, but I have 2 of them. So when you do this, we're actually going to keep the E on that alkane, alkene, alkyne suffix. Then what we're going to do is on whatever our suffix is, in this case the all, we're going to add a multiplying prefix indicating exactly how many times that functional group shows. So whether it's a diol, a triol, a tetrol, or so forth. Then again, as fairly normal, we're going to add the locator numbers for each one of those functional groups right before the prefix. So in this case, I have an alcohol as my highest priority. It is a pentane molecule, as I have 5 carbon chain. So this becomes a pentane. Again, we kept that E diol. Again, 2 of them. Now, including the number, I have, when I number the system, either way, either carbon I start with, I put an alcohol in the 2 and the 4 position. So I'm going to minimize the numbering of that amino group. So this becomes a pentane 2,4-diol. And again, that amino is located at the 1 position. So bring this all together, I have a 1-amino pentane 2,4-diol. However, when working through our naming, we've only talked about cases where our amines are primary amines, as in they're NH2 groups. But part of the issue is that amines can also be secondary or tertiary. So in these cases, this means they have multiple carbon atoms bound to that central nitrogen. So in this case, we can account for it by first identifying our main alkyl chain. So in this case, it's going to be our ether main chain here. So that's going to establish the root. Then we're going to treat the other groups as alkyl groups. So this means that I'm going to treat this carbon as a methyl group and this carbon as an ethyl group. And when we add them to the name, we're going to use an italics N instead of the locator. So instead of saying they're at the 1 position or 2 position, I'm saying that they're at the N position. So let's see how this applies. So again, my priority functional group in this case is an amine. So that gives me my suffix. I have a 5-carbon chain, so this means I've got pentane. So I have a pentanamine again. Got a lot of these today. Now, when I number the system, again, I'm trying to minimize the number on that nitrogen so it gets the 2 position. So I'm not minimizing the priority of that ether, so it gets pushed down. So my main chain is a pentanamine, so everything else gets treated as substituents. So numbering that, it becomes a pentan-2-amine. So my substituents includes both the traditional methoxy group at the 5 position and a methyl group at the 3 position. But it also includes those N groups, so that N-ethyl and that N-methyl. So now I have to go ahead and add all 4 of these guys as prefixes before my pentana-2-amine root name. So to do so, we're going to name them alphabetically. So we go ethyl, now then methoxy, but we have a little bit of fun here at the end because I have 2 methyl groups. So when I name this, I start with that N-ethyl, then I go to that 5-methoxy. Again, that O just sneaks out the Y. And then I name this as a dimethyl species because I have 2 methyl groups. One's located at the N position, one at the 3 position. And then finish with the root name ped-10-2-amine. So again, a lot to take in here, but you can kind of see how we can start with those identifying our priority functional group, then name the molecule much according to our normal rules, only adding in that suffix, a multiplying prefix occasionally, and again, location numbers. So next time we're going to dive in dealing with more complex functional groups. Until then, take care.